So we did A yesterday. So let's take a look at B. And let's remind ourselves what we're getting out of this. Okay? So if I have the quadratic function, f of x is equal to 3x squared minus 7x plus 1. You know the graph of that's a parabola. Right? And if we want to find the x-intercepts or determine whether there are any x-intercepts in the graph of this parabola, we set the right-hand side equal to 0. Right? We're setting y, which is the same as f of x, equal to 0. And then we solve for x. Okay? And so we can use the quadratic formula to solve for x. Okay? Determine if there are any x-intercepts in the graph of the parabola and where they're located. Okay? So in this example, a is equal to 3, b is equal to minus 7, c is equal to 1. So x is equal to negative b plus or minus the square root b squared minus 4 times a times c over 2a. Substituting into the formula, negative b is the negative of negative 7 plus or minus square root. B squared is minus 7 squared and minus 4 times a, which is 3, times c, which is 1. All divided by 2 times a, which is 2 times 3. All right, so we have the negative of negative 7 is plus 7. And remember, under the radical, you got to follow order of operations. Minus 7 squared is 49. And then multiplication, 4 times 3 times 1 is 12. And the denominator, 2 times 3 is 6. Do we know how many x-intercepts there are now in the graph of this parabola? How many are there? 2, right? Because the discriminant is a positive number, right? That's what we pointed out yesterday. So, x in this case is equal to 7 plus or minus, what's that, square root of 37 over 6. So, square root of 37 can't be reduced, right? So, those are our two values of x, recognizing the use of plus sign and then the minus sign, right? So if you want to, you can write them out. X is equal to 7 plus the square root of 37 over 6, and x is equal to 7 minus the square root of 37 over 6. I do believe that Weber sign forces you to write out both of them, doesn't it? Right? It doesn't, there's no plus and minus symbol. You got to write out each x-intercept. And then I think you got to write out the smallest one first and then the large one, so you got to know, right, which number is bigger. Okay. Yeah, so these are the x-intercepts, and these are the exact value of the x-intercepts. Okay. All right. Any questions on that, ladies and gentlemen? All right, so flip over your page. We'll do sort of an exhaustive example. We're going to graph the quadratic function f of x, determine the domain and range, the vertex, the x-axis symmetry, x and y intersect. That'd be a good test question, right? Give me a quadratic function, and then answer all these questions concerning. All right, so we have f of x is equal to minus x squared plus 3x plus 4. So what's a equal to in this case? -1, right? That minus sign is a -1, right? B is equal to 3, C is equal to 4. Now, is this parabola going to open up or open down? It's going to open down, isn't it? Because a is negative. Now we don't know. We don't know where it's located in the coordinate plane yet, but we will. All right. So determine the domain range, the vertex. So remember, there are two ways of finding the vertex, right? Complete the square, and then there's what I say is the shortcut method, right? So I'm going to do the shortcut method. If you want to complete the square, that's fine with me. I'm going to do the shortcut method. And so you know the x coordinate, okay, for the vertex is h, and h is equal to negative b over 2a. So b is equal to 3, and a is equal to -1. We got double negatives here, right? So we have -3 over -2, right? So negative, negative. Now I could have, if I wanted to, might have been better to write this as minus b in the numerator divided by 2a. We would have -3 in the numerator divided by 2 times -1. And then we would have -3 in the numerator divided by -2 in the denominator. And now you see negative over negative is positive. Okay. And so this is equal to 3/2. So the x coordinate for the location of the vertex is equal to 3/2. The y coordinate is equal to k, and k is equal to f of h, which is f of 3/2 in this case. So we put 3/2 in for x here on the right-hand side of the function. We have minus 3/2 squared. Remember, the minus sign doesn't go inside the parentheses, right? You square 3/2 and then take the negative of it. And then plus 3 times 3/2 and plus 4. All right, PEMDAS. So exponentiation comes first. 3/2 squared, square the numerator, square the denominator, right? 3 squared is 9, 2 squared is 4. So 3/2 squared is 9/4, and then we take the negative of it. We have minus 9/4. And then 3 times 3/2, right? The 3 is the same as 3 over 1. And so when you multiply 3 over 1 times 3/2, you get 9/2. And then we have plus 4. I'll leave that alone for now. So k, now we got to do the common denominator. The common denominator is 4. So we have minus 9/4. 9/2 multiply top and bottom by 2. So we get 18/4. And then 4 is the same as 16 divided by 4, right? 4 is equal to 4 over 1. And you multiply top and bottom by 4, you get 16 over 4. Now we can add the numerators. Minus 9 plus 18 is 9, and 9 and 16 is 25. So the y coordinate for the location of the vertex is 25 fourths. So the vertex, which is at the point HK, the vertex in this case is at the point 3/2, comma 25 fourths. Now, if you were instructed to, could you now write this in standard form, this quadratic function? Yeah, right, because you know h and k. Yes, sir. Well, this is plus 4. 4 is equal to 4 over 1. And when you multiply top and bottom by 4, you get 16 over 4. Yeah, so we could write this in, for kicks and giggles, write it in standard form now, right? F of x is equal to a times x minus h squared plus k. A is minus 1, or just minus, and then x minus h is x minus 3/2, and then plus k is plus 25 fourths. So that's the equation of that's the quadratic function. This quadratic function in standard form, right? They both have the same parabola, same vertex. All right, and they both have the same value of a. When you write standard form, you get a different value of a. You did something wrong. All right. You with me? All right. Axis of symmetry. Axis of symmetry is a vertical line that goes through the vertex. And the equation for a vertical line is x equals something. X equals what in this case? What's the equation of the vertical line that goes through the vertex? Huh?
Is x equals 1?
Nope.
X equals 2.
Yeah. Where'd you get 1? Just guess it.
I thought I remembered it being like a vertical line.
Yeah, so it's x equals 3/2, right? When we graph the quadratic function, you'll see that. The vertex is located at 3/2, 25 fourths, and the vertical line goes through the vertex. So the equation of the vertical line is x equals 3/2. All right. X and y intercepts. Well, the easiest intercept to find is the y-intercept, right? Can you tell me what the y-intercept is in the graph of this quadratic function, just by inspection? Yeah, it's 4, right? Y equals 4. If you put 0 in for x on the right-hand side, those two terms are 0, and you're just left with 4. Right? So the y-intercept is y equals 4, right? Or the point 0.04. Now, what's a little harder is the x-intercepts, right? Or just the parabola across the x-axis, if at all. So to find the x-intercepts, you set the right-hand side equal to 0, right? So we have minus x squared plus 3x plus 4 is equal to 0. And so now we got to factor the left-hand side. But as I think I've told you, I have a hard time factoring when the number from the x squared is negative. So I'm going to divide or multiply both sides by -1. It doesn't matter whether you multiply or divide by -1, it has the same effect. And when you divide by -1, right, the sign of each of those coefficients changes, right? So instead of minus x squared, we have plus x squared. Instead of plus 3x, we have minus 3x. Instead of plus 4, we have minus 4. And now I can factor that. The factors into x minus 4 times x plus 1. And so now by the zero product property, either x plus 4 is equal to 0, or x minus 1 is equal to 0. Did I do that wrong? Oh, it's x minus 4. So either x minus 4 is equal to 0 or x plus 1 is equal to 0. So solving this first equation, we get x equals 4, or the point 4, 0 is an x-intercept. We solve the second equation, we get x is equal to minus 1, or the point minus 1, 0 is an x-intercept. Any questions? Yes, ma'am.
Could we also do the x-intercepts with that by doing the quadratic formula?
Yeah.
Okay.
Yeah. Yeah, the quadratic is a backup.
Okay.
Yeah. Right? You could have used the quadratic formula, right? You know what A is, you know what B is, you know what C is. Get the g values of x in the quadratic formula. There's actually a third method to get the x-intercepts. Using this equation. Set the right-hand side equal to 0, and you can do the square root method. But you're doing the square root method with fractions. All right. So the only thing left is to determine, well, to sketch the graph and determine the domain and the range, right? So see, right? So this is a crude sketch. So the vertex is at 3/2, 25/4, right? So 3/2 is halfway between 1 and 2, right? So here's, say, x equals 1, x equals 2. So 3/2 is right here on the x-axis, right? 1.5. And then 25/4 is 6 1/4. So it's like 1, 2, 3, 4, 5, 6. Never make my graph big enough. 7. So 25/4 is like 6 1/4. So, right, 6 1/4 is above 6, less than 7. So here is the point. Here's the vertex, right? Approximately where the vertex is. And 3/2, comma, 25/4. Okay? And we know it opens down because A is negative, right? The parabola opens down. All right, the y-intercept we said is at 4. y equals 4. 2, 3, 4. So it's going to cross the y-axis here at y equals 4. Now, the x-intercepts are at -1 and +4, right? So here is -1 on the x-axis. So here's going to cross here at -1, and it's also going to cross the x-axis at 4. Now, this is supposed to be, the parabola is supposed to be symmetric, but you may have a hard time getting it perfectly symmetric. So with the vertex, the y-intercept, and the two x-intercepts, we can get a crude graph of the parabola, right? Starting here at the vertex, it's going to cross the y-axis at 4 and cross the x-axis at -1. That's the left half, right? And now the right half is going to cross here at x equals 4. So this isn't going to be I don't know if this is going to be really, right? This is supposed to be symmetric, but you know how it is. My drawing skills are really bad. That's supposed to be symmetric, right? The axis of symmetry is the vertical line that goes through the vertex and crosses the x-axis at x equals 3/2. So the parabola to the left of that dashed vertical line is supposed to be symmetric to the right half, right? The parabola to the right of that vertical line. Okay. That's not that bad, actually, my graph, right? It's hard to stand up here next to the board, right? 6 inches from the board and try to get something, right? It's not like standing back 10 feet. All right. Domain and range. What's the domain of all quadratic functions? Yeah, that's the easy part, isn't it? Right? The variable x can take on any value, right? From -infinity to +infinity. In interval rotation, -infinity to +infinity. The range is the y values, right? The y coordinates. Is there a minimum y coordinate? No, because the graph goes down forever. Is there a maximum y coordinate? What's the maximum y coordinate? Yeah, right? 25/4. There's no point on the graph with a y coordinate greater than 25/4. So the range is y is less than or equal to 25/4. Which is that in interval notation. Okay. Well, that was an interesting little problem. Okay. All right. Any questions on this? Yes, ma'am.
For the range, is it always gonna have a bracket if it like stops at the number?
Yeah, if it's closed circle, yeah, it'll have a bracket. Open circle, we'll have a parenthesis. All right. So you'll notice that on WebAssign there are like 3 problems where you're throwing an object up in the air. Okay. You got to calculate the maximum height of the object and when does it hit the ground and things of that nature. Well, the position of the, like you're throwing a ball up in the air, the position of the ball, right, as a function of time follows parabola, okay, a quadratic function. And so this is what this little paragraph explains. Okay. So in the example, right, it says from the top of the building, 160 feet high, a ball was thrown upward with an initial velocity of 64 feet per second. And so the height of the ball is given by s, right? S is a function of time t. And so s is equal to minus 16t squared plus 64t plus 160. You recognize that's a quadratic function. Okay? So the height of the ball is a function of time, right? It's represented by a quadratic function. And so the graph of a quadratic function is a parabola, right? So we can calculate when the ball reached its maximum height above the earth, okay? And we can calculate what that maximum height was, and we can calculate when the ball will hit the ground. Now, math is very visual, so it's always important, I think it's important to draw a good picture of the problem. So here is the earth, and here is our building that's 160 feet tall, right? And from the top of the building, we throw a ball up in the air, okay? Now, so this building, right, is 160 feet tall. Now, what's important to realize is that the flight path, the quadratic function does not give you the flight path of the ball. The ball is thrown up in the air from the top of the building, and it's thrown straight up in the air, and then it comes straight back down and hits the ground. Okay? It goes straight up, and it comes straight down, right? Gravity eventually causes the ball to stop going up, pauses in midair for a moment, and then it comes crashing down to the earth. Okay? What S tells us is the height of the ball as a function of time. So we have S of t, right, our quadratic function. S of t is equal to minus 16t squared plus 64t plus 160. Now you notice that t equals 0 when the ball is released, thrown up in the air, it's 160 feet in the air. Right? T equals 0 is when you toss the ball up in the air. S of 0 is equal to minus 16 times 0 squared plus 64 times 0 plus 160. This term is equal to 0. This term is equal to 0. And you're just left with 160. So initially, the ball is 160 feet in the air because it's at the top of the building. Okay? That makes sense. All right. So what this function does, again, tells you the height of the ball as a function of time. And it is a parabola. So at t equals 0, right, the height of the ball is 160 feet. And then this is not the flight path of the ball. This is the height of the ball as a function of time. And so the height of the ball as a function of time looks, is that supposed to be a half of a parabola? I didn't do it very well. There we go. Okay? There's some point in time where the ball's at its maximum height. And there's a point in time where the height of the ball is 0 feet above the earth, right? It's sitting on the earth. Okay? So this is not the flight path of the ball. This is just telling us how high the ball is as a function of time. Start here at t equals 0, and then at some point in the future, the height of the ball is 0 feet above the earth. Okay? So in A, you're asked, when did it reach its maximum height? Well, its maximum height is at the vertex, right? This is the vertex of the quadratic function. So we got to calculate k. That gives us the maximum value of the parabola. So S of t is equal to minus 16t squared plus 64t plus 160. So you can see in this case, A is equal to minus 16, B is equal to 64, C is equal to 160. So we got to calculate the location of the vertex. So H, the x coordinate, is equal to negative B over 2A. Negative B in this case is minus 64. And 2 times A is 2 times minus 16. So we have minus 64 over minus 32, which is equal to 2. 2 what? Time has units. So what's the units for time? Seconds, right? So 2 seconds after you throw the ball up in the air from the top of that building, the ball reaches its maximum height. Okay. What's its maximum height? The value of k. Right? That's the y coordinate of the vertex. So k is equal to f of h, which is equal to f, oops, I said f of h, I have it. It's s of h, which is s of 2 in this case. So we put 2 in for t on the right hand side. We have minus 16 times 2 squared plus 64 times 2 plus 160. And now it's PEMDAS, right? So 2 squared is 4. 4 times minus 16 is minus 64. 64 times 2 is 128. Minus 64 plus 128 is 64. 64 and 160 is what? 224. So A was, when did it reach its maximum height? So this is A, right? H equals 2 seconds. That's when it reached its maximum height, right? 2 seconds after the ball was thrown up in the air. B is what was its maximum height? That's K. So its maximum height is 224. 224 what? Feet. So 2 seconds after the ball was thrown in the air, it reaches maximum height, and then it reaches maximum height of 224 feet, right? So over here, ball's thrown straight up in the air, and then comes straight back down, right? When it gets its maximum height here, it's 224 feet above the earth. Okay. In C, when will the ball reach the ground? Well, when the ball reaches the ground, right, this is it right here. When the ball reaches the ground, the height of the ball is 0 feet, right? So you got to take the quadratic function and set it equal to 0. Set S of t equal to 0. and then solve for t to find out how long it is before the ball hits the ground. Okay? So, in C, we set S of t equal to 0 and solve for t. Okay? We know if t equals 0, it's 160 feet above the ground. We have to find the value of t where it hits the ground over here. So we have minus 16t squared plus 64t plus 160 is equal to 0. Now, you'll notice that each of these coefficients is divisible by 16. More importantly, minus 16. So if I factor out a minus 16, I have minus 16 times t squared minus 4t minus 10. Now you can divide both by minus 16 if you want to get rid of the minus 16. Because what you got to set equal to 0 and solve for t is t squared minus 4t minus 10 is equal to 0. Right? You divide both sides by minus 16, you're just left with what's in parentheses. That does not factor. So how do we find the value of t? Quadratic formula. Okay. So A, right? Now this A, B, and C is different from up here. A is equal to 1, B is equal to minus 4, C is equal to negative 10. And so T is equal to negative B, which is negative of negative 4, plus or minus the square root. B squared, which is minus 4 squared, minus 4 times A times C over 2 times A, which is 2 times 1. Negative 4 is plus 4. And then under the square root, minus 4 squared is 16. And then minus 4 times 1 is minus 4. Minus 4 times minus 10 is plus 40. And 16 and 40 is 56. Now, before we simplify square root of 56, okay, there are two values of t, right? This value of t over here, do you think we use the plus sign or the minus sign? Plus, right? So our value of t is 4 plus the square root of 56 over 2. Square root of 56, does that reduce? 56 divided by 2 is 28. 28 is 14. So this is square root of 56 is 4 times 14. So we have 4 plus, right, square root of 4 is 2. Square root of 14 over 2. And now you got to divide each of these terms by 2. 4 divided by 2 is 2. And then these 2's cancel. And we're left with 2 plus the square root of 14 seconds. That is the exact answer, right? The exact amount of time it takes for the ball to hit the ground. Using your calculator, it comes to 5.74 seconds. As an approximation. That's how long it takes for the ball to hit the ground after you throw it up in the air. Now, on the exam, you'll have much nicer numbers than these. You'll have whole numbers, you'll have numbers you can work with, okay? Because there's no calculators on the exam. But for illustration purposes, right, we can use not so nice numbers. Okay. So now you got everything you need to successfully complete the web time homework by tomorrow night.